Good morning, children, and welcome to all of you in the physics class. Today I will explain the new chapter Work, Energy and Power. That is given here. What is work? The term work in physics, we can say that when any object after applying the force can be displaced from one place to the another as shown in the picture which is given here. Suppose that one object is initial position of the body and after applying the force F it moves s distance and reached at the final position, then what is the formula of work done? Work is equal to force into distance moved in the direction of force. That is mathematically W is equal to F cross S. So what comes the unit? The unit of force is here Newton and distance is unit is meter. So work unit is Newton meter. Okay. Now another unit is joule. Newton meter is also called joule. So going onwards, for calculating the work done by force F under these circumstances as shown in the picture here, F is horizontally applied and S is the displacement in slanted or inclined plane that is given here. Then the baseline that is AB here is S cos theta. Then for using the formula work done W is equal to F cross AB, we get here W is equal to Fs cos theta. W is equal to Fs cos theta, or you can say that force into component of displacement in the direction of force. Okay. So what comes another? There are some cases which are given here. Firstly, we start the case number 1 that is given at the above. Case number 1, if the direction of displacement is same as that of the applied force, then we can say that theta is equal to 0 degree. After putting this value W is equal to Fs cos 0 degree, we get W is equal to Fs because cos 0's value is 1. Hence, in this case, the work done is maximum. Now, in the second case, if the direction of displacement is perpendicular, that is theta is equal to 90 degree. After putting it in the formula W is equal to Fs cos theta, we get here W is equal to 0 because cos 90 value is 0. Okay, that is given here. Now, moving forward, one example is very interesting which is given here, that is if a coolie having luggage on his head goes from one end to the other end of a platform, he is doing no work in terms of physics. Why? Because the displacement is making an angle with a gravitational field 90 degree and cos 90 value is 0. So work done against the gravitational field is 0. Hence in this case the work done is 0 or minimum or there is no work. Case number 3 that is given here, if the direction of displacement is opposite to that of applied force, then theta is equal to 180 degree, and in this case the value of cos 180 degree is equal to minus 1. So above equation becomes W is equal to minus Fs. Okay. So we get displacement is 0, the work done will be 0. If we see that the work done will be 0 in the following two conditions, that is given if there is no displacement in the body, if the displacement is perpendicular to the direction of applied force, then we can say that the work becomes 0. There are two types of work which are given here, positive and negative work. Positive and negative work. When the force and displacement both are in the same direction, then we can say that work is positive. that is W is equal to Fs. When a force is applied in the direction of the moving car, the car gets accelerated. This is positive work done by the force. Vice versa, if force is applied in the opposite direction of the moving car, then angle theta is equal to 180 degree, then work done is equal to negative. This is negative work. Okay. So when anybody asks you about the negative work, then you can say that after applying the force, the car backward direction, and the force is applied and make the angle 180 degree, then cos theta is equal to, that is cos 180 degree, which is gives minus value, so work is negative. Now moving forward, units of work I have already explained earlier. The SI unit of work is Newton meter, or we can say joule, which is given in this picture. 1 joule is equal to 1 Newton meter. Another units which are given here that are larger unit, 1 kilojoule, that is 1000 joule, and 1 megajoule, that is 10 to the power 6 joule. One more interesting thing, 1 kilogram weight into meter is also can be converted in 9.8 joules. This is sometimes used in numerical purpose. Now work done against gravity. Work done against gravity. How can we calculate it? Work done against gravity, because work can be calculated by the formula force into distance and downward force, that is mg here and height is h here. So we can say that the work done against gravity becomes W is equal to mgh, where m is the mass of the object, small g is the gravitational acceleration, and h is the height of the following or falling object. What comes forward? From the above discussion, we conclude that work is done when a force produces motion. That is, work is done when a force changes the position of an object in some cases. However, force does not produce motion until a work is done. Let us see this example, which are given here. A weightlifter holding 50 kilogram weight in this outstretched hand keep standing in the some position. Then although there is no motion, but still the man feels tired and starts sweating because his energy is being used up in doing work. When the man is holding a weight in his outstretched hand, work is done because the weight is stretched, the muscles of the arm and changes their shape. The heart has to pump. Many complex chemical reactions taken place in the body. All these changes require energy, and hence work is done by the man holding the weight to supply this energy. So we cannot say that every change involving work. In other words, we can say that work is said to be done when a force produces a changes in the position, velocity, shape, chemical composition, temperature of body, etc. Okay. Now, what is energy? Next is energy. Energy, the capacity of body for doing work, is known as its energy, and its measurement by the total work the body can do under the circumstances, that is position, configuration or motion in which is placed. Okay. For example, the wound spring moves the hands of a watch, and so it has energy. Wind energy of some work is done by its when it's drive a boat, where wind is actually air. There are synonyms of air which is used here, that is wind. Now, all of you know that energy cannot be created and cannot be destroyed. Only transformation of energy will be happen. So we can say that energy can be transferred only. That is given in the formula also, or in the big box that is given, energy transferred is equal to work done. There are different forms of energy which are given in the below, that is mechanical energy, In this energy, machine or any human body do the work and convert in the any motion or displacement or any other things, then we can say that the mechanical energy. Second is heat energy, the energy released on burning coal, oil, wood or gas, and the heat energy. We also receive heat energy from the sun. Now another examples are chemical energy, electrical energy, nuclear energy, solar energy. As you know about chemical energy, energy which is obtained by chemical reactions; electrical energy, which is obtained by the differentiate electrical potential energy; nuclear energy, the energy produced in the process of nuclear fission and fusion. So we can understand better all these energies. Suppose solar energy, the energy related or radiated by sun is called the solar energy. Inside the sun, energy is produced by the nuclear fusion reaction. 4 hydrogen nuclei combine to form helium nuclei. Now, next is kinetic energy. What is kinetic energy? Kinetic energy is nothing but it is the energy when any object is in motion, that have the velocity, that have the acceleration, then we can say that it have the kinetic energy. What is the formula of kinetic energy? We can get it. Suppose that any object have the initial velocity u and final velocity v and travels the s distance, then we can use the third equation of motion, that is v square is equal to u square plus 2s, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the distance traveled by the object. Suppose u is the 0 here, then v square is equal to u square plus 2s. Similarly, if v square is 0, then what comes? That is given here, because any object is moving and after applying the brake it is stopped. Then final velocity 0. When 0 is equal to v square minus 2s, then what comes? V square is equal to 2as, or s is equal to v square upon 2a. By using the formula kinetic energy, that is work done by the force F in bringing the body to rest, that is Fs. After putting F is equal to ma, s is equal to s, the value of m is m, a is a, and s value is v square by 2a. Then we get kinetic energy is equal to half m v square. It is very important in the numerical purpose also. So we can say that by the above formula, kinetic energy of a body is directly proportional to the mass of the body, that is given here. We can look at mass of the body, and secondly square of the velocity, that is given square of the velocity of the body. So we can conclude it here today. And most important, the unit of energy is also joule. That is very important for you. Now another parts that is remaining here, I will explain it another video. Thank you all of you. Thank you for watching us. Thank you very much. Okay.